Everyone. If you can see me, if you can hear me, just write you in the chat box. You know the drill. Awesome. I think I'm going to be visible in 3, 2, and 1. Awesome. Hi guys, how are you all? Who all are present? Hey guys, if you can see me, if you can hear me, just make some noise on the chat box and tell me if you are able to see me or not. Awesome, awesome, awesome. Hi RB Rathi. Hi guys. Hi Rowdy, how are you? Let me just keep my phone for some time here so that I can read your chats. Hi Tech1000, Ruchi, Janvi, King of World, Diksha, Narayana, Aman, Ayush, Ruchi, Tejaswini, Mantha. Iron Man is here. Hi Iron Man, how are you? Sri Hari, Siddharth, Nishant, Ankit, Reddy. Then we have Divyansh. Oh my god, too many names. I can't even go through the names. You guys are so fast. Very nice, guys. Good to know that all of you are doing fine. JEE cancelled. No. JEE is not cancelled. JEE is happening. Okay. For people who are appearing for 2020 JEE examination, the examination is still on. No confirmation from HRD ministry. Okay. Do not believe on any rumors as of now. Okay. Cool, everyone. I hope all of you are doing fine. Very nice, Ayush. All the best for your 2020 examination. So guys, I hope all of you are doing fine and I'm back with another session. You know that at 9 o'clock we meet for people who are aspiring for JEE 2021. Yes, the people who are moving to 12th standard. So this is specifically the time of the day when you meet with me, with Arvind sir and with Harsh sir for your PCM preparation for JEE examination. Yeah. So guys, all my 12th standard students, today's topic is another topic from Current Electricity, and the name of the topic is Voltmeter and Ammeter. If you are a part of our Telegram group, you know this. I've already told you people. Okay, cool, awesome guys. So I'm now keeping my cell phone here so that I can look at the screen properly. Okay, so guys, all of you who are new on the channel and don't know me yet, let me start off with my introduction as always. This is me, your Suri Sir. I am an alumnus of IIT Bombay, and on this channel, I am more commonly known as Mugambo. Why am I called Mugambo? Is because when you will crack this examination of JEE, Mugambo khush hoga. Okay? Also, if you are new, then you might not be aware about the schedule that we follow for JEE 2021. So guys, every day at 9 p.m. we meet for theory discussion, like this is the slot for theory. And 8 p.m. on certain days we meet for MCQs discussion. What are those days? Like Monday, yesterday we discussed MCQs on Kirchhoff's law. Also on Wednesday and Thursday. Okay, so whom do you meet for chemistry? You meet Harsh sir. He is your chemistry master teacher. This is Arvind sir. He is your mathematics master teacher, and this is me, the poor fellow who tries to teach you all physics. Okay, I hope all of you are now aware about the schedule. Yep. Okay, I'm good. Narayana, thank you for asking. Cool. Also guys, if you are new to the channel, then definitely I would ask you people to subscribe to the channel right now and press the bell icon so that whenever your Mugambo, your Suri Sir comes live, you get the notification. Okay, awesome. So guys, you know that Vedantu has a humongously awesome and humongously big platform for aspiring students of JEE and NEET and many more standards as well. So we have a particular type of platform and a subscription which is going on specifically for students who are moving from 10th to 11th or 11th to 12th standard. So let me tell you what exactly is that subscription plan. So guys, we call that subscription plan as Vedantu Pro. Yeah. Okay. What makes it pro is something that I'm going to explain it to you very soon. Important is this link which is available in the description box of this video. Okay, so when you will click on that link, it will direct you to this page where you will have to select your standard. If you are in 11th or moving to 11th, select it as 11th. If you are moving to 12th, select it as 12th. select the examination that you are preparing for. If there are NEET aspiring students, please select NEET examination over there. After that, what exactly will you get in the subscription over here is the live interactive sessions by your master teachers, including me, obviously, and assignments and notes, study material, a lot of test series and analysis. So guys, in brief, if I have to tell you what exactly are you going to expect out of this, you're going to get around 40,000 plus hours of live teaching, 20 plus master teachers who have ample amount of experience of this field and examination, a lot of tests and assignments, option to choose between Hindi and English as the mode of communication, continuous review about the areas of your improvement will be given you as the part of your analysis of performance, and unlimited access to micro and crash courses. So guys, this is how basically the Vedantu platform looks like. Okay, this is V Pro platform. You can see Pulkit sir is teaching. This is the chat box. This is the Q&A panel where students ask their doubts simultaneously. This is the live session. Okay, all these sessions happen live every day. Okay, and this is basically where the concept explanation is being done by your teachers. Okay, cool. So if you are interested in this subscription plan, then we have a monthly, quarterly, half yearly or annual subscription available. As you can see that if you keep on moving towards a longer subscription, the pricing per month will be reduced. And moreover, if you are interested, okay, if you are interested and if you're going to enroll right away, you're going to get additional 15% discount. All you have to do is go on this link available in the description box, and don't forget to use this coupon code, that is SMPRO. You will get additional 15% discount on any of these subscriptions. Okay guys, I hope things are clear to everyone. Awesome, cool. So guys, let's go, let's start the session. Are you all ready? Make some noise guys. Are you all here? Are you all ready for the session where we are going to speak about voltmeter and ammeter? Hi guys, are you all ready for the session to start? Shall we start? Thank you Divyan Sharma. I also get a lot of positive energy when you guys make noise here and make your presence felt by giving me all this energy. Yeah, awesome. Okay, Bits Pilani, Goa have civil engineering. Definitely civil engineering is going to be there in every college. Thank you, Rich Tumukuntla. Good name. Okay guys. So guys, before we talk about ammeter or voltmeter, there is a device which you must all have seen in the laboratories already in 11th standard, I'm sure. Okay, when you go to your physics laboratory, your seniors last year, they used to do that experiments with the help of something called as a galvanometer. Okay, now what exactly is a galvanometer? Its working and its construction is something that we are going to see in the chapter of magnetism. But right now, let's understand what exactly galvanometer is. So guys, galvanometer is an instrument which is used to detect and measure very small amount of current which are of the order of microamperes or milliamperes. That means 10 to the power minus 6 to 10 to the power minus 3 amperes order of current is being measured by this device called as galvanometer, and it's a bidirectional device depending upon the direction of flow of current. So if the current is going in a certain direction, it will move say towards the right side. If the current is going on the other direction, it will move to the other side, as in the pointer. Okay, and remember the symbol, it's going to be a circle in a circuit. This will be connected in a circuit. Say this is the part of the circuit where you want to measure the value of the current, so you are going to connect it, okay, maybe like this. So it will tell you how much amount of current is flowing in the circuit, provided that the current is of the order of milli or microamperes. If the current value will be more than milliamperes order, say it is even 1 ampere, the device will get damaged permanently. You will not be able to use it again. It may catch fire as well. Okay, so that's why galvanometer has a limitation that it can only measure very small amount of current, and hence comes the need to create a device to convert this device into something which can measure the current which is of the order of not just amperes, but maybe hundreds of amperes, thousands of amperes, or much bigger than that. So what is that device, guys? Yes, you know the name of the device. It's called as ampere meter or a meter. So it's the device which is used to measure current, which is obviously relatively larger in amount. Okay, that means of the order of amperes, or maybe of the order of hundreds or thousands of ampere. Okay guys, cool. Now remember, because ammeter is going to measure current in the circuit, We want the same current to flow through the ammeter which you want to measure. So definitely you will connect it in series with the part of the circuit which you want to measure the current for. Okay. Also, for an ideal ammeter, we consider that the resistance of the ammeter is going to be 0, but practically it's not going to be 0. You can see that ammeter is connected in series for the resistance for which you are interested in measuring the value of the current which is flowing in it. Okay. Okay, and practically the smaller be the resistance of the ammeter, more accuracy will be there in the reading. Please remember that. That's more of a practical point. Okay, this is more of an ideal point, and the second one is more of a practical point, that you would want your ammeter to have as minimum of a resistance as possible. Okay, now moving on to the part which will tell us how exactly you are going to convert a galvanometer, this device, into this device. Okay, so let's see. So how we are going to convert a galvanometer into ammeter? So this is your galvanometer. It already has some resistance, say Rg. Okay. Now you want an ammeter to be formed, but you want the ammeter to have very less resistance. So what you are going to do, you are going to connect a resistance in parallel to this galvanometer, which we call as the shunt resistance. I am writing it as Rs. Okay, I am not writing it as S, rather I am writing it as Rs. What is S or Rs? It's basically called as your shunt resistance, which is very small in amount. Okay. Now what will happen if you are connecting a resistance in parallel? You know that whenever we connect resistances in parallel, the equivalent resistance is found as 1 upon R1 plus 1 upon R2 plus 1 upon R3, like that. Okay. And the final resistance value, the equivalent resistance value, comes out to be even smaller than the smallest of the resistance. So you're already connecting a very small resistance in parallel to the galvanometer. So obviously a very very high amount of current will pass through it. You know that your galvanometer can only sustain a current of order of milliampere or microampere max, minimum micro or maximum milliampere. So you want Ig to be very small. So what happens here, say this junction is P and this junction is Q. So what you're doing, at point P, this is that current which you actually want to measure, I. So when it reaches point P, you are giving it a bypass. What is that bypass? It is the shunt resistance, which is very small. Current would always want to go in the path. Okay, current would always want to go in the path where the resistance is less. So I minus Ig is relatively, I minus Ig is much greater than the value of Ig. Okay, and now because you are connecting both of them in parallel, so definitely same amount of potential drop will happen. So if we look at that potential drop which is happening on the shunt resistance, that value is going to be I minus Ig, the current value, into the shunt resistance, and the same amount of potential drop is happening on your galvanometer, which is Ig into Rg. Okay. Why shunt is small? Because we want very small amount of current to go through the galvanometer, because it will get damaged if it is a current more than milliampere. So we want the higher order current to pass through the shunt resistance, and shunt resistance is very small, so it will have maximum amount of current going through it. So what comes out to be the value of the shunt resistance? If you rearrange this, it comes out to be Ig into Rg divided by I minus Ig. Okay, which you can say almost equal to Ig Rg divided by I. Why did I do that? Because of this factor. You can write Ig minus I minus Ig almost equal to I. I minus Ig is almost equal to I, because Ig is very small in comparison to the current which you want to make it flow, if this happens. Okay. Cool, guys. What is the meaning of shunt? Shunt is the bypass. Cool, everyone? Okay, Nikhil, welcome. Now, this was basically your ammeter. Please remember this particular equation. This is very important equation, that you are sending the same amount of potential on shunt resistance and to the galvanometer. Both of them are connected in parallel. Okay. Now, coming to the next device, which is voltmeter. Don't worry, guys. Your understanding will get even more clearer when we are going to solve questions based upon the ammeter as well as on voltmeter. So don't worry, guys. Okay. Now, what exactly is voltmeter? You know that voltmeter, as the name also suggests, it's a device which is used to measure the potential difference between any 2 points. And because you want to measure the potentials, so potentials has to be measured same, which is going to be the same potential which is dropping on the element where you are interested in finding the value, and voltmeter should have the same value of potential. That's why your voltmeter will always be connected in parallel. Okay. Ammeter is always connected in series. Voltmeter as a device will always be connected in a parallel possibility. Okay, so that is why you see that if you are interested in finding the value of potential drop between P and Q, so you are connecting it across this resistance R, you are connecting the voltmeter in parallel. Okay, now for an ideal voltmeter, what would you want? You want no current or minimum current to go through the voltmeter. That's why you would want it to have infinite resistance, because it will have infinite resistance, very small amount of current will pass through it, and practically more be the resistance of the voltmeter, less be the current which will pass through it, and more accurate will be the reading of that voltmeter. Okay, now practically how you are going to convert a galvanometer into voltmeter, you know that if I will connect a series resistance which is very high, R value is very high in comparison to the resistance of the galvanometer, then overall resistance will become Rg plus R, and because overall resistance is very high, and now this entire circuit element is becoming a voltmeter, you are going to connect it into the circuit parallel to it. Yeah, so this part is your voltmeter and you are connecting it in parallel, so it's going to draw a very small amount of current. So I current is coming here and Ig is going in the voltmeter, and overall almost I current is going, or I minus Ig is going to the circuit. So we can say that the potential that you want to measure is going to be Ig into Rg plus R. What is that R? It's not called shunt resistance, by the way. It's just called a very big resistance R. Okay guys, so you can rearrange the values to find out the value of capital R also. Capital R is going to be V by Ig minus Rg. Don't have to memorize this. Okay. Why it is connected in parallel? So that it will have the same potential drop as the element where you are interested in finding the value of potential. So the value of potential will be same on the circuit as well as on the voltmeter. Okay. Very nice, Ritika. Awesome. Okay, cool guys. Now, there is a surprise which is coming soon, by the way. There is a brand new series which is being planned by Vedantu, and what we are going to call it? It's some master talks with achievers. Okay, this is something which even I will be very honest, even I am not completely aware about, because it's a surprise which is going to get revealed very soon. Stay tuned to the channel or the Telegram group. We are going to tell you what are those master talks that are going to happen, who are those personalities whom we are going to meet very soon. Okay, awesome. Yep, cool guys. Now let's try to understand what we have learned with the help of the examples. So look at this question guys. Question says that we have a galvanometer whose resistance is given to us as 50 ohms, and it is going to give you full scale deflection as 1 milliampere. So what is 1 milliampere? Is basically the galvanometer current, 10 to the power minus 3 ampere. Okay, its resistance is given to us as 50 ohms. Okay, now what do you want to do? You want to make it a voltmeter which can measure a voltage, maximum voltage of 20 volts. So what you're going to do, you're going to take your galvanometer, you're going to connect a big resistance in series, and this can measure the voltage V, okay, such that it is going to get Ig current. So what did I say? For this conversion to be possible, the value of V should be equal to Ig, and two resistances are in series, should be equal to Rg plus R. What is the value of V that we want to measure? That's 20. Ig value is 10 to the power minus 3. Rg value is 50, and R value is being asked by the question. Okay, so to this 10 to the power 3 minus 3 comes to the other side, and it becomes R plus 50, which is equal to 20,000. Okay, this means what? R will be equal to 20,000 minus 50. So the resistance that you need to connect in series is 19950 ohms. This big of a resistance that you need to connect in comparison to 50 ohms. See how big of a resistance that you are connecting. Okay, Ig is constant. Ig is basically the maximum current which your galvanometer can sustain, and every galvanometer will have its own Ig value. Okay, perfect. Very nice, Narayana. because it is voltmeter. No, this entire arrangement is now voltmeter. This resistance is not voltmeter. This entire arrangement that I have made, this arrangement is now called voltmeter. When a galvanometer has a resistance connected in series, this blue box is called voltmeter. Not only capital R is voltmeter, the entire blue box that I have drawn is voltmeter, which will be connected in parallel to a circuit. So this is where your circuit will be connected. Which circuit? The electrical circuit, and this is the device that you are connecting in parallel. Okay, Divyansh, I answered your question. Okay, cool. Now guys, next question. This time you have to convert your galvanometer into an ammeter. So what does question gives you? It gives you the value of Rg, which is 100 ohms. Okay, it has Ig value, which is given to us as 0.5 milliampere. You want to convert it into an ammeter whose range is 10 ampere. You can see that the value of Ig is very small in comparison to I, and question is asking us to find out the value of shunt resistance. Okay, so what do we do? If you have a galvanometer, you are going to connect a shunt resistance in parallel to the galvanometer. So when I current is what we are interested in measuring, Ig will go to the galvanometer and I minus Ig will go to the shunt resistance. Okay guys, now what does this mean? This first of all means that this entire arrangement is ammeter. The blue circle that I am drawing, this entire circle is your ammeter. So let's try to find that out now. What exactly is going to the value of Rs? So I say that I minus Ig into Rs, the potential drop on shunt resistance, should be equal to the potential drop on galvanometer. So IR for shunt resistance and IR for galvanometer. Now you see that the value of I is very greater in comparison to Ig. So what I'm going to do, I'm going to write I minus Ig as almost I. How can I say that? Look at this value guys, this is 10 amperes, this is 0.5 milliamperes. In comparison to 0.5 milliampere is a very small value. So I'm going to write it almost as I into Rs equal to Ig Rg, which means what guys? Rs will come out to be Ig Rg divided by I. So Ig value is 0.5 into 10 to the power minus 3. Rg is 100 and divided by the value of I, which is 10 amperes. So this 10 cancels this 10 and this 10 multiplies with 0.5. So answer comes out to be 5 into 10 to the power minus 3 ohms. Look at the value of the shunt resistance. Such a small value of the shunt resistance you are going to connect. 5 milliohms. Yes, 0.005. Perfect, Janvi. Very well. Understood now, Satvik? Very nice, guys. Very nice. Yes, Tushar. Sir Taklu. That's my new look. But you have been, I think, new on the channel. 10 to the power minus 3. Not 10 to the power 3. Okay, Divyansh? 10 to the power minus 3. Because it is milliamperes. Okay. Formic, I'm not sure it's useful for 10 standard or not. But definitely for 12 standard. Okay, guys. Let's move on to the next question. Now this says that you have a 50 and 100 ohm resistors which are connected in series. So this is 50 ohms and this is 100 ohms which are connected in series, and this connection is connected with a battery of 2.4 volts. Okay, so this is going to be connected with a battery of 2.4 volts. Okay, so when a voltmeter of 100 ohms is connected across 100 ohm resistance, we know that voltmeter will always be connected in parallel. So this voltmeter that I'm going to connect it in parallel with the 100 ohm resistance, and the resistance of the voltmeter is also 100. So it's like a 100 ohm resistance is connected in parallel. Okay, so now what will be the reading of the voltmeter? So all you have to tell is how much potential drop is going to happen over here. How much potential drop is going to happen now on this part. So guys, if you look at this, this is just like a question where you have 3 resistors given to you with a battery of 2.4 volts connected. Okay, so this is 50, this is 100, and this is 100. So you know that now the question is asking you to find out the value of the potential drop here. 50, 100 and 100 in parallel will become 50 only. So this is what basically happens. Yes guys, so this is 50, this is 50, this is 2.4 volt. So can I say that equal amount of potential drop is going to happen on both the resistors here? So what will be the potential drop here? Will be 1.2 volts. That will be the reading of the voltmeter as well. Okay, perfect guys, awesome. Answer is option C. Very well done. Very well guys, because it is equally dividing the resistance now. So the potential value will come out to be 1.2 volts. If your voltmeter would be ideal, because this voltmeter already has a 100 ohm resistors. If it was an ideal voltmeter, it will not take any voltage, it will not take any current. But because it is a real voltmeter, it has a 100 ohm resistance. Okay, so that's why it's going to have some impact on the overall potential drop. Okay, awesome. Now this one. This question says that 1 milliampere current is flowing through a resistor of 1000 ohms. So you have this 1000 ohm resistance through which what is happening? A current of 10 to the power minus 3 ampere is flowing. Now to measure the correct potential difference, the voltmeter which is to be used should have resistance about which, what should I say? What should I speak about, or what can I comment on the resistance of this? What should be the value of this R? Can I say it should have a very less amount of current flowing through it? Maximum amount of current I should flow through this resistance only. For voltmeter to have minimum amount of current flowing through it, its resistance should be as big as possible. So we can say that R should be much greater than 1000 ohms. Getting it guys? Does it make sense? Perfect. Yes, answer is option D. No. If voltmeter will have zero resistance, then it will be the most easiest path for the current to follow. Current will not even go to the 1000 ohm resistance. Current always want to go to the path where it has minimum resistance. So we want the current to go through the 1000 ohm resistance. We don't want it to go to the voltmeter. Yeah, because that is what we want. Okay. Okay, perfect. Yes, Narayana. Cool guys. Next one. Now this says that an ammeter gives full scale deflection when the current is 1 ampere. Okay, that means what? Ig value is 1 ampere. Relatively a bigger value of Ig is given to us. Okay, and the value of I which is given in the question is 10 ampere. Here you can say that they are comparable, so you cannot neglect it. So the ratio of resistance to the shunt resistance will be how much? So we know that I minus Ig into Rs should be equal to Ig Rg. Just to take you back to a question where we did this. Yeah, so we are writing this equation. I minus Ig into Rs should be equal to Ig Rg. Okay, the potential drop that is happening on shunt resistance is equal to potential drop on the galvanometer. So this is 10 minus 1 into Rs. Ig value is 1 into Rg. So Rg by Rs comes out to be 9:1. That means answer comes out to be option D. Okay, everyone, answer comes out to be option D. Now this one, in order to pass 10% of the main current through a moving coil galvanometer of 99 ohms, the resistance of the required shunt should be how much? So what do I say? Let's assume that in the circuit, whatever shunt resistance that I am going to connect, its value is unknown, but the value of Rg is given to us as 99 ohms, and assuming that some 10 ampere current is coming. So out of this, what do we want? We want only 10% of this value. That means we want only 1 ampere to go through the galvanometer, and how much remaining? 9 ampere we want to go through the shunt resistance. Okay, so 10% of 10 ampere is 1 ampere. So remaining 90% of 10 ampere is going to be 9 ampere. So this goes to Rg and this goes to Rs. So now what I can say, that I minus Ig into Rs should be equal to Ig into Rg, the value of the voltage on the branches here. So this value is 9 ampere. I have chosen this 10 ampere. Okay, you can choose this current as 1 ampere also, you can choose it as 100 ampere also, because it is talking in terms of percentage. So this is 9 into Rs, Ig value is 1 and Rg value is 99. Rs comes out to be 99 by 9 or simply 11 ohms. Got it, guys? Okay. Cool, everyone. Answer comes out to be 11 ohm. It will be independent of the value of the current that you chose. I chose it as 10 ampere. You can choose it as you want. You can choose it as 100 ampere. You can choose it as I also. The answer will not change. Okay, very good, guys. Very good. Now this one. So if an ammeter is to be used in place of a voltmeter, that means now you want to convert an ammeter into voltmeter, then we must connect with the ammeter. So if you want an ammeter to be used as a voltmeter, then it must have a very high resistance, and that is only possible when you are going to connect a very high resistance across this ammeter to convert it into a voltmeter. Okay, so that's a logical question, a trivial, or you can say a conceptual question. A very high resistance in series is to be connected, just as we did when we were talking about conversion of your galvanometer into a voltmeter. Okay, this is something that we studied somewhere over here. Okay, do you see this, guys? We have to connect a very high resistance in series of the galvanometer. Now instead of galvanometer, what you have is basically an ammeter, and to this ammeter what we are doing, we are connecting a very high resistance in series. So answer is going to be option C. Okay, very good. Okay, now this one, guys, an ammeter with internal resistance 90 ohm reads 1.85 amperes when connected in the circuit, which already has two resistances connected. So what happens here? Say you have a 700 ohms here, 410 here, and 90 ohms here. So the value of the current which comes here is given as 1.85. So what do we say? We say that the value of this current I is going to be V by R equivalent, and R equivalent is basically 410 plus this is 500, 500, and this is 1200. So this is the value of the current which is passing through this circuit, which is given to us as 1.85. Okay, when you have a battery connected of whose voltage is V, that means V will be equal to 1200 into 1.85. Now what happens if you do not have the ammeter? Without it, how much amount of current was actually passing? Because of the connection of the ammeter, the circuit had its current changed. But now if you have the same battery connected, it's the same battery connected, so how much amount of current will now pass? So V should be equal to I dash into new resistance. Okay, guys, so I dash should be equal to V by R new. Okay, so what is V? V was 1200 into 1.85 divided by R new, which is just the addition of 700 and 410, which is coming out to be 1110, which you can see that is going to be greater than 1.85 ampere, or you can simply say that when you connect a ammeter in the series, you are adding resistance, you are reducing the current. Yeah, so when we say that I is equal to V by R, the voltage of the battery is not changing, but when you are connecting a resistance in terms of ammeter, the current was decreasing. So this was coming out to be 1.85. Now you reduce the value of resistance by removing the ammeter, so definitely the current will increase. So what will happen? If the actual current was to be measured, it was actually greater than 1.85. Okay. Okay, now tell me this one, guys. An ammeter reads up to 1 ampere. Its internal resistance is given to us as 0.81 ohms. To increase the range to 10 amperes, how much do you think should be the value of the shunt? So again, I minus Ig into Rs should be equal to Ig into Rg. So this value is 10 minus 1, that is 9, into Rs. This value is 1. This is 0.81. So Rs comes out to be 0.81 divided by 9. So the shunt resistance comes out to be 0.09 ohms. That means option C. Okay, everyone? Okay, guys. So the answer comes out to be option C, not option D. 0.81 divided by 9 it is. Okay, Anuradha, welcome. So guys, next is your homework question, very similar to what we have been solving today. We have an ammeter of 5 ohms. Its resistance is given and it reads this much. So it is to be used to read 100 volts. How much resistance is to be connected in series? So V is equal to Ig into R plus Rs. You want to find out R, which is going to be V by Ig minus Rs. So this is, sorry, Rs, not Rs, but Rg, the galvanometer current. So this is what you have to find out the value of R. Okay. Do solve it and tell me the answers in the comment section. Okay. Cool, guys. Okay. Also, for people who are new and want to know how can you cover the topics that I have done before this session, for that all you have to do is look for a specific playlist. What do we call that playlist, or what should you be looking for? You should be looking for this particular playlist. Okay, there we have divided the sessions chapter wise, also subject wise as well. So you'll be able to find out everything and you'll be able to cover up everything that I've taught before this: electrostatics, Gauss's law, capacitance, and current electricity, which is going on right now. Okay, awesome. Also, for my students who are going to appear for JEE 2020, I know the times are difficult, but you can definitely use a dose of motivation. Guys, these are Vedantu's ex-students. These guys made it to IITs by being in the top 3 ranks out of top 50. I would say they are the toppers of Vedantu. Okay, this is Rajdeep, who got All India rank 38, Chirag got All India rank 41, and Sumit got All India rank 1 in PWD category. So guys, if these guys can do it from their home, then definitely you can as well. Okay. Also, to help you with that, you can also utilize this final few days to give a awesome sprint to your own preparation by being a part of Vedantu's crash course, where we are giving away 90 plus live sessions. A lot of testing will be done. You will have the analysis of your own performance, so you can boost your own scores. A lot of rank booster quizzes during the sessions, and a lot many things are happening on the session itself. Okay, so if you are interested, then the last batch has recently started. You can be a part of it just by going on this link, which is available in the description box as well as in the comment section. You can find the link in the comment section as well. What you have to do there, you have to use this coupon code SMCC, and the course, which is actually worth rupees almost 25,000, could be yours for just rupees 3,999. Okay. Also, if you are interested in just a test series, then we have a test series which has started on 22nd of June, where we are giving away 10 full-length tests. Definitely live discussion of the papers and unlimited doubt solving is also being done over there. So to be a part of this test series, the link is again available in the description box or on the comment sections as well. All you have to do for this is use this coupon code SMTEST. The test series is actually worth rupees almost 10,000. You can use this and be a part of this test series by enrolling for just rupees 1399 because of the coupon code SMTEST. Okay, guys. I hope it's understandable to everyone. Also, there is a Telegram group where we keep on sharing the assignment solutions, study material, and daily updates. Link of that is available in the description. Do use that and be a part of the Telegram channel of Vedantu. Okay. So guys, if you enjoyed studying today with me, the voltmeter and ammeter part, go through the video one more time if you found it relatively confusing. In the first time, it comes up as a relatively confusing concept, but trust me, if you will solve questions, you will be able to understand it. Okay. So guys, if you enjoyed studying, then definitely I would want you people to press that small thumbs up. Okay. Press that bell icon. Tell your friends about these lectures and subscribe to the channel, guys. Press this bell icon so that whenever your Mogambo comes live, whenever your master teacher comes live, you get the notification. Okay, guys. So with a mission that we will crack JEE 2020, JEE 2021, or if you are a 2022 aspirant, with a motive that during the lockdown time, during difficult time, the learning won't stop. This is the time to take your leave, and I will see you very soon. In fact, I'll see you tomorrow itself at 3 o'clock. Okay, till then, keep studying, keep enjoying physics. More importantly, as I always say, stay safe. Bye-bye.